we saw in the table view when we were in the app. Then we proceed to do what? We grab the object at that particular row. We then update the text label on that cell to be whatever the description is of that object. So in short, the object that we put in the object we put in objects was essentially a date, and then we're just adding that to the descriptive text on the cell itself, and then we return the cell. So most of that was just configuration details, maybe new in terms of the code we're seeing, but not all that interesting, except for this if condition here. What do you think the purpose is of the relative complexity of these several lines? Why this queue? Why this reusable thing? What's going on?
Make sure you don't overwrite the cell, or just make sure it's unique.
OK, so make sure you don't overwrite a cell. Make sure it's unique. True, but we could do that by just allocating a new cell for every one of the dates in this table, or every one of the words that I want to put in this table. Why else might I be introducing this complexity of some kind of queue of reusable cells?
You want to change the value inside? Or?
Want to change the value inside. So that's true, but why? What's the motivation? Let me press further. Suppose that you can view 10 cells on the screen at once based on the height of your iPhone and the height of your font, and you have allocated, let me say, if you only can display 10 rows at a time, but you've got 100 dates because you've hit that button 100 times, technically, only 10 of those cells need to be in RAM at any given time, because the other 90 are down here. The user's not going to be able to see them, so why bother keeping them in memory? So if I give you that insight, why are we apparently using this trick? What's the motivation? Yeah? Exactly. It all boils down to memory usage and memory management. So to your comment earlier about really the spirit of keeping memory usage low, you could absolutely just allocate 100 cells for 100 items. And frankly, the user's probably not going to notice any latency when scrolling through them, because 100 is not that big. But suppose for Evil Hangman, you decided to make an application that displays all 100,000 plus words at once, and you scroll through that, then you probably will, depending on the hardware, start to notice some latency, because there's so much RAM being taken up by all of those rows, and it's completely unnecessary. Of the 100,000, you can only see maybe 10 of them at once, so you only need to have 10 actually resident in memory at a time. So this queue is meant to be a performance optimization. So if you've ever used an iOS application that starts to feel very laggy for some reason, it's probably because they were trying to do too much, and potentially some of that work was unnecessary, as might be the case here. So this is illustrative of that kind of design paradigm, especially as your data sets get larger and larger. OK, let's not dwell too much on the other methods, but happy to take questions if they arise or are on your minds now. All right, so that just leaves us with one last class, the detail view controller. So this guy, if I go to the .h file, looks pretty uninteresting, except for the fact that he's got a UI label and he's got a detail item. I also see mention of IB outlet. What is that again? What's an IB outlet? OK, good. So it's a reference to something that's declared in the nib. So it's a means of my code talking to my drag and drop interface. And in this case, the thing in question is a UI label. So how can I pull up Interface Builder and see that interface? What file do I want to click next to follow this trail of breadcrumbs? Yeah, so detailviewcontroller.nib. And if I look there, looks like indeed someone has just dragged and dropped a UI label. I know that because I can see its description down over here. And when in doubt, too, if I go to the right-hand panel and open that up and notice that I'm on the identity inspector, Xcode has a habit of dumbing things down by saying label hyphen detail view controller ... when really that's not all that interesting programmatically. You want to know what type of object is that really. So in the identity inspector, which you can see at top right, you can see that, oh, the thing I've just clicked is actually an instance of UI label. That is what I have dragged and dropped. And again, that's the connection between code and the drag and drop interface here. So let's answer just one last question before we put this template aside. How do we somehow pass control off from the master view controller to the detail view controller? How do we make that transition? We haven't looked at the code yet per se, but where would you look if you wanted to answer that question? How does clicking on a cell lead to a state transition? What file should we look at? OK, so we want to look at the method that's called when it's actually clicked. And how can I chase down that answer?
We passed in a selector into
Okay.
It's found in the master view controller.m.
Okay.
You did a control F for selector.
Selector. Okay. So there's a selector for insert new object. We saw that before. Only one match.
There should probably be a protocol somewhere that defines the interface between master and...
Okay, so let's see. If I scroll down here, cell for row, can edit row at index path, table view commit editing style. That doesn't sound right. Oh, this one, interesting. And that's exactly right. What Peter proposed is that presumably there's some method that's defined, maybe in that protocol we saw at the very beginning of the story, that is what's called when a user clicks on the row. And indeed, that's the case. This is a common paradigm, clicking on the row in a table. So Apple went ahead and implemented that base functionality for us. So if we want to listen for that key press on one of those rows, we apparently just have to implement a method called table view did select row at index path. So what's going on in there? Well, notice first it takes two arguments. The first is a table view. So that's what table view did the user click on. Maybe there's multiple ones on the screen. And what, again, to be clear, is an index path? Section and a row number. So it's going to be like 0, something for the 0th section, 0 index, and the actual row number. All right, so what are we doing here? We again seem to be doing what's generally called lazy loading. If the detail view controller does not yet exist, if it's nil, what do we actually do? We allocate it by calling detail view controller alloc. We initialize it with nib name, detail view controller. Notice when you call this method, you don't say .xib. Bundle is just referring to what folder is it in. We just say nil because it's in the default. Everything is organized at this top level. And so once these lines of code have executed, we now have a pointer to an object of type detail view controller. So we've got the thing in memory now. We just have to transition from the master to the detail. So what am I going to do next? NSDate object. So just to be clear, what is this next line of code doing? On the right-hand side, we have what type of object? What is underscore objects? An NS mutable array. So if we index into it at a current row, that's going to return an object of what type, apparently? An NSDate. And on the left-hand side, we are allocating what? Let's a little pop quiz here. A pointer, good, to an object of type NSDate. So we're not allocating an NSDate. We're allocating a pointer to an NSDate. So it's just 64 bits, most likely, not the full-fledged object. Next, we do self.detailViewController. Detail view controller. What is self.detailViewController? Where did we see that before? So it's a property that we declared earlier. And .DetailItem, well, what's DetailItem? It's going to be set to the object. Where did I see DetailItem? If I go to detailViewController.h, DetailItem was apparently a property that I stored here. It's a type ID. What does ID mean? Any object. It's a pointer that could be nil, but it's a pointer to any object. So this is just a generic way. We could have been more explicit and stored NSDates. Whoever wrote this template decided to just genericize it a bit. So we're storing something of type ID there. So lastly, in this line, we call push view controller animated yes. So the fact that it slides from left to right, as we can see, is the result of the following. Notice the sexy left to right behavior like that. But if I instead change the Boolean yes to Boolean no, stop the current running instance and rerun, and now go ahead and +++, click here, much less elegant. Right? That's what makes Apple devices Apple, the sexy little slides back and forth. All right. Whew. Questions? OK, so you may never again use a master detail view controller template, and that's fine. The goal of this was not to walk through just templates that Apple hands to us, but rather a number of the design paradigms that they're leveraging as a result of this so that you can either start with something like this or something simpler, like the simple single view application, and begin to wire things together in the same way. And what this is particularly illustrative of is wiring stuff together, not using interface builder and dragging and dropping blue lines, but writing much more code and doing it manually and precisely. IB outlet in this guy over here? Good question. So detailed description item. For some reason, the developer who wrote this template seems to have gotten bored with actually doing the wiring, and rather the coding, and decided to wire it up. So we can go to the nib file for detail view controller, and if I control click on this thing, we will see that detailed description label is wired to file's owner, and who is the owner of this file, apparently? The controller, the detail view controller, because recall, that's the guy that initialized the nib with nib name. So he is the file's owner because he's the guy that called this nib file to life. So that was the one instance of dragging and dropping. Everything else in the master was done in code.
Okay, so that's why it's weak. Like in the property.
Yes. Oh, I'm sorry. I missed that part of the question. Yes, so if we go into detail view controller, we have seen a slightly different feature here. These attributes associated with properties. The reason that this here is weak is that we do not want the, what's the best way to say this? This property in the detail view controller is pointing to an object that doesn't need to be kept around, particularly if the detail view controller, once it goes out of scope, as by hitting the back button, disappears from memory. We don't want to have a strong reference to the detail description label, lest that blue line keep the detail view controller in memory unnecessarily long. So this really boils down, the motivation for this is because the detail view controller is coming and going, we want iOS to be able to reclaim that memory, and so we don't hang on to, in a strong way, these blue lines. And that's the first instance I think we've actually seen of that use of weak for that reason. Good question. All right, why don't we go ahead and take our 5-minute break here. We'll come back and start building something from scratch. And we're back. So recall that there's been a checkbox that we haven't checked thus far because we've been using nibs instead. And nibs are a deliberate design decision because they've given us much more low-level control over our user interface. But popular these days is another feature that we keep unchecking known as storyboards. Anyone familiar with these yet? Use storyboards. If we check that, what we get out of the box? So this is Apple's way of trying to simplify the user interface process further, at least for applications that follow some common iOS paradigms, like the table view that we just saw, the utility application that we just saw, and making it less necessary to write code to somehow make view controllers interact. So if we follow this next screen by clicking Next with View Storyboards, what we'll get is an application that looks a bit like this. And let me go ahead and open up a different project called Storyboard from tonight's code, and this will give us a view of exactly what's different. In the Storyboard folder, the story begins as usual with main.m, and then up here we seem to have main view controller and flip side view controller. So what I've done was start with which template as a starting point apparently? So the utility application, and a couple of you did this, I think, accidentally, maybe last week when following along, since it was pointed out that your nib file looked a little different, or your UI looked a little different. And indeed, if we go to main storyboard.storyboard, we see a user interface that looks like this for a utility application, and it appears that we're seeing like two nibs simultaneously, the main view controller and the flip side view controller's UI in the same screen. But they're somehow connected via this transition, generally known as a segue. And indeed, that's what it is, because when you use a storyboard, you essentially get one master file for your user interface, and you wire this up all within itself. And you specify in code exactly what you want to happen when A segues to B. So the one line of code we need to draw attention to really is just this. If I go into my main view controller, notice that this is actually pretty straightforward. I've simply implemented a separate method this time called prepare for segue sender. And this is the method that's apparently going to be called whenever the user induces a transition from the first controller to the second controller. And you can see what it's doing here. If segue identifier is equal to the string, quote unquote, show alternate. So this string, show alternate, is completely arbitrary. It could have been foo, bar, baz, whatever. But it's a string that we'll see elsewhere. And apparently what's happening, if that is the identifier of the segue that the user wants to happen by having interacted with the application, we are going to call destination view controller on the segue, set delegate to self. In other words, before the user transitions from this side to this side, we apparently want